Hey guys, how's it going? So, I want to discuss another concept today um, that I've been kind of pondering upon for a little bit of time, and I've thought a little bit about. The core kernel of the idea is basically kind of trying to understand whether there is a difference between a blueprint and a structure, between a schematic and an object, and if so, what is that difference? So just to kind of clarify this, let's say if you had a perfect representation, a perfect schematic of a computer chip, or let's say if you had the perfect blueprint of how to construct a car, right? It gave you all the details, the tiny measurements, the material, the structural details, composition, all of those things. And if you had the perfect schematic, is there a meaningful difference then between the schematic and that chip or that computer? Uh, and if there isn't, what is that difference? If that difference does exist, or is it just basically the same thing? And like I don't claim to have like any like exact answer, but I think this question is very interesting, and I think kind of going through trying to answer that does you know lend itself to some kind of pretty interesting concepts, I think. So to kind of try and answer this question, one of the things that we need to think about is to some extent the relation between matter and energy and information and computation. I promise I'll kind of try to tie it back all the end, but stay with me on this segue, and I think like it's interesting. So like in general in physics, right, you could basically say that, well, what is the world made out of? The world is made up of matter and energy, right? The entire universe, it's made up of matter and energy. And matter and energy are again like basically the same thing. It's like they're equivalent, like any physicist would tell you, they're equivalent and they're basically the same thing. It's just a slightly different manifestation, right? And you can say that matter and energy make up the universe. In a similar vein, you could basically say that you could also say that the entire universe is basically just made up of information and computation, and that's all it is. And I'll get into that. But also, as we know, information and computation are also kind of equivalent, and they're equivalent in a similar way to how matter and energy are equivalent. So information and computation, like they're again very similar, kind of the same thing. Like if you want to kind of compute anything, well, you need to store that computation. And how do you store it? You store it as information. So computation is in a sense nothing but information. It's information about how to modify other information. And and information is kind of only meaningful it can if it can mutate, if it can change. And the only way that information can mutate or change over time is through computation, which is stored as information. So that's kind of how they're like almost equivalent, right? And and how information or computation, you can say, kind of makes up the universe is, you could basically, I mean, there are like various different types of arguments, right? There is like the Stephen Wolfram, who says that, who has this theory that if you can actually kind of look at the entire universe as like a computational graph of nodes and edges, and then you can kind of generate the universe kind of from that, right? You could say that, oh wait, like I mean, if you look at kind of the universe around us, well, you've got like the physics, the core atoms, all of these structures, but all of these atoms are basically also a particular type of structure, with protons and neutrons arranged in a certain way and electrons spinning around it in a certain way. And what is chemistry? From physics, you get chemistry, and that's basically all of these atoms arranged in a certain way, right? And they react and change in a certain way. And you could say that, oh, the structure, like how they are kind of configured, that's information itself, and how they kind of change over time. That's well computation. And if you run that, you'll get the universe, right? And I mean, there are like kind of these like philosophical, slightly metaphysical sorts of things where it's said that, oh, well, actually, the universe might be like a supercomputer, or something like that, right? But pretty much every process that you look at in the universe that we study, you can kind of look at it as information and computation, right? You look at genetics, right? You genetic code, it's information, and mutation of that code is computation. And if you basically apply the natural process, like the natural evolution process of natural selection, you end up getting like that's basically again computation, right? It's evolutionary computation on these different sequences over time, and then biology is a result of that computation over a chemical substrate, right? In your nucleus, in your biological cells, with chemicals running through, etc., right? And then you through those natural processes you kind of get what we see around us, and those natural processes itself are kind of functions that are again information and computation, right? And you kind of go all the way and you basically get like intelligence, right? And intelligence we now say is like artificial intelligence, machine learning. It's sort of a neural network, and that's also a certain function which is stored, which computes the same thing, right? So you go from physics, chemistry, biology, sociology, and all as a chain of computation. Even the matrix, right? If you said that, oh, you're constructing the matrix, and the matrix is supposed to kind of represent this world, well, what is the matrix? It's basically a computer system, right? It's just generating what a person should be seeing. And I mean, there is all of these like kind of metaphysical, neo-metaphysical sort of theories, right? Oh, are we living in a matrix or whatnot, right? Uh, and and I mean, even if you kind of look into the core, like I mean, I'm by no means like a physicist, but if you look into, I think the core physics of it, my basic understanding is that even there, these are kind of linked. Like I mean, like matter and energy are linked to information and computation just fundamentally, like through entropy, right? Both entropy is a property of both, and I think even like from what I understand, the black hole information paradox kind of talks about it, right? Like when you kind of lose particles, you lose information, and then there was some of the kind of issues around it. Again, like don't kind of quote me on it, but like I was fortunate enough to attend like a Leonard Susskind lecture, and like through that, I kind of understood that what he was when he was kind of describing those equations, it did kind of show that energy and information are also just linked kind of in the same way. And and if you look at kind of the universe as a whole, right, you could also say that, well, the universe as it exists today is in a certain state, right? As if you have a gameplay in a certain state, and that's what the current information of the universe is, and it's going to keep changing over time as the universe is changing, and that information is stored in the universe itself, and that becomes a bit more interesting. Like even if and the funny thing is that, like even if you kind of define the core concepts or the core equations which kind of define what the universe is, right? And as the universe expands and grows and changes, you have like the many worlds interpretation in like quantum mechanics, right? Even there, like even like a minor change in any of these configurations can lead to like very different sorts of universes, right? And you could look at those equations itself as certain types of functions which are generating the universe. So they're kind of deeply linked. And now I'll kind of try and tie it and kind of get back to the question that why is this fundamental concept of like physics, matter, energy, and computer science, information and computation, which are so deeply linked, so intertwined in this question about like if you have a blueprint or a schematic, is that any different or is that meaningfully different from the actual object? And uh, and if you kind of think about it, right, like it's like let's say how do you construct like a perfect schematic, right? Like let's say if I wanted to define a perfect schematic of a car, right, I would need to define each and every part of the car. These are the parts that make up the car. These are how they're arranged. These are how they're connected. This is the material that constructs this part, and this is the chemical composition of this part, etc., right? And maybe you can have a perfect schematic, right? But then in how much detail do you have to go, right? Like you can basically say that, hey, these are all the parts, this is how they're geometrically arranged, and this is the chemical composition, and then you can build the car, and you can say that, hey, that's a perfect schematic. But is it? Because if you want to define what the chemical composition is, you need to define chemicals, you need to define compounds, you need to define the elements, you need to define, oh, if this is an element, what is an atom, right? And what is its structure? And then you kind of realize that as you need to go further, you need to basically define what the universe is. But even if you kind of say, okay, that's just one way. But let's say even if you have a perfect car, right? Um, can you define actually exactly what that car is? Because that car, once that car exists, is a very particular thing. It's a set of different atoms arranged in a certain way, and all of those atoms have certain states. They have certain properties. They have certain quantum states, right? And all of these are kind of changing in real time as it's interacting with the environment. And obviously, the blueprint or the schematic doesn't capture that. And if it were to capture that, if it wanted to capture a car, a computer chip, it would need to capture the quantum properties of every single quantum particle that is in that car. So, in a sense, it would have to be the car itself. So, to perfectly describe the car, you would have to construct the car itself. And that I think kind of gets into a little bit of this idea as well. Oh, well, to perfectly describe the universe, you would kind of need to construct the universe itself. And maybe the schematic or the blueprint is basically realistically nothing but a compressed version of that car. It's just a compressed way of representing what that car is. So it's just a compressed representation, and but that compressed representation is also kind of part of the universe. So you could, in a sense, say that the universe itself has various compressed representations of itself within it. It sounds a little bit weird and trippy, but it's interesting, and maybe that's what it is, right? Maybe that's what it is. Like any way you kind of define the universe through a set of functions or theories or mathematical representations, even if you write it down on a paper, it's information that is stored on atoms, right? And uh, and you kind of get back to this idea that to represent the universe you have to construct the universe, and if you have any computation which represents the universe, it has to be stored somewhere, and that's the substrate, the atoms or the quantum superposition of the particle spins, right, as you have in quantum computation, and that's also in the universe. So the universe really exists as an informational representation of the universe itself, computing and constantly changing over time. And this computation happens using energy on matter, which are basically the same thing. Uh, so, so it's all a bit kind of weird and trippy almost. And I'm just kind of wondering if I've like kind of summarized all that I can think of about this. But realistically, I think that's just kind of the idea where I think there's something just phenomenally beautiful about this idea that uh, matter, energy, information, and computation are all deeply linked and kind of the same thing in a sense, or like maybe we'll discover them to be the same thing. Like I am not a physicist, I don't play one. I know a little bit about software engineering and computation, but it does seem to me that these core kind of things being deeply linked and defining how you construct itself is just quite fascinating to me deeply. So that's it. Thanks. See you guys.